Welcome to Brain Vision.
In this question, we have an electron accelerated across a potential difference of about 0.1 kilovolts before passing through a thin slit. We want to first ask ourselves if we need to use relativistic formulas. That is, does the velocity reach near to the speed of light? Right. So there's two ways to take to actually look at whether an electron or a particle is relativistic or not, and that is if the kinetic energy is close to our rest energy. So rest energy being mc squared. In this case, for electron is about 0.511 MeV or 511 keV. Now compare this with the kinetic energy, which is just Q times V, should be 0.1 keV. This is much lesser than the 511 keV rest energy. Therefore, this would not be relativistic. Now, if you want to be very clear, you can look up the velocity as well. You can assume that it is non-relativistic and find its velocity. So this half mv squared equals to 0.1 keV. Right, so you can do some conversion. From keV to joules. You can find the velocity by taking 2 ke by m, take the square root, and we should get about 5.93 times 10 power 6, which is 10 to the power of 2 orders of magnitude smaller than c. Right, therefore it is much smaller than c, and therefore is non-relativistic. Right, we can ignore the relativistic effects. For the second part of this question, we want to find the slit width, and to do that we use the single slit diffraction equation. That is d equals to d sine theta equals to n lambda, where n is equals to the order of the minimum. D is the slit width, sine theta is the angle, right, of which the minimum is at, lambda is our wavelength. So what we first need to do is to find what is the wavelength of the electron. We can do that by using lambda is equals to h over p, so equals to h over mv. Now since we already have the velocity from our previous parts, we can just substitute that in. You get a wavelength of about 1.23 times 10 power minus 10 meters. And now we are ready to find the slit width, which is d is equals to n lambda over sine theta. So for the first order of minimum, we can substitute n equals to 1, and our theta is given to be 11.5. It's 1.23. And this should give us about 6.16 times 10 power minus 10.